All right, this is standard 46, solving systems using substitution. So again, we're still solving systems of equations, except instead of graphing, we're using a different method, which is called substitution. So it's our second method. We're going to do a third method coming up, but we're doing the same thing as graphing, except a different process. But we are finding the solutions. So to substitute means to replace. So if you have a substitute teacher, the teacher replaces your normal teacher for the day. Okay, so here's the steps. So pause the video and jot these down. The first thing we're going to do is get one of the variables by itself. So sometimes this will already be done, so you won't need to worry about that if it is already done. The second thing, we're going to substitute what that variable equals into the other equation. Okay, after that you're going to solve that new equation for the variable that is in it. And then step number 4, you're going to plug the value for that variable into either equation to solve for the last missing variable. And then you're going to write your answer as an ordered pair just like we did when we were graphing. Okay, so the types of answers you'll see, just like when we were graphing, we had one solution, no solution, or infinitely many solutions. So with one solution, we'll still have an ordered pair. This is just like when you were graphing and you drew your lines and they met at one point. We wrote down that ordered pair. That's one solution. That's what your answer will look like. For no solution, you'll go through and solve it, and if you end up getting an answer that looks like one of these, 4 equals 7. Well, we know that's not true. 4 does not equal 7, so that's when you'll know to write no solution. 6 equals 5. That's not true either. 9 equals 2. That's not true either. So anytime you get a number equals a different number when you go through and solve, then you'll write down no solution. And then infinite solutions, if you go through and you get a true statement, 5 does equal 5, 3 equals 1, or 3 equals 3, I'm sorry, 1 equals 1. Those are true statements. That means there's infinite solutions. That's as if we graphed it and it looked like there was only one line. They were on the same line, and so all the points on the line were a solution. And so that's what that will look like when we go through and solve these. I forgot to mention for no solution, just like we were graphing, they were parallel. So if we were to graph those, these would be parallel, but this is what the answer will look like when we're using substitution. Okay, so example 1. So if you remember, our first step is to get one of the variables by itself. Well, if you notice this top equation, y equals 5, the y is already by itself. So this is good for us because we can move on to the next step. So we're going to plug in what y equals. So y equals 5 in this case. Something very simple. This is a really easy problem. We're going to plug in 5 for y in the other equation. So I'm going to rewrite this second equation exactly like you see it, x plus, but instead of y, I will now have 5 because y equals 5. And then I'll finish off my equation, bring down my equal sign, bring down my other 5, and then solve. So this is just a normal one-step equation, so x plus 5. So to cancel that out, move to the other side, we're going to subtract 5, subtract 5. So x equals 0, because 5 minus 5 is 0. So that means my x is 0, my y is 5. I have my answer. So it's one solution, because I did get one answer. And I, of course, write it as an ordered pair, 0, 5. Your x term, and then your y term. Okay. Example 2. So if you notice here, y is still by itself, so we're good. We can skip that first step. But y equals 2x plus 1. This is in slope-intercept form, but y is by itself, so it's a little bit longer this time. We're going to plug this whole thing, 2x plus 1, into the other equation where you see y. So we're going to substitute it in. So I'm going to rewrite this bottom equation. 3 times x plus, and then instead of y, I'm going to plug in 2x plus 1, because that's what y equals negative 9. I'm going to go ahead and get in the habit of plugging in or putting in parentheses, because most of the time you will have to do that. There's nothing to distribute though, because technically this is just a positive 1 in front. So I really technically didn't need to put the parentheses this time. But normally there might be a number in front here, so we're going to want to put the parentheses. I just got in the habit of doing that. So because there's nothing to distribute, I can bring down 3x plus 2x plus 1 equals negative 9. And then I go ahead and solve. So combine like terms. You have 3x plus 2x. So we have 5x plus 1 equals negative 9. Minus 1. Cross those out. 5x equals negative 10. And the last step, divide by 5. So x equals negative 2. Okay, so we have our x term. Now we need to plug in what x equals into one of the equations to find y. Now, always choose your easier one. I personally think this top one looks easier, so I'm going to plug it into that. So y equals 2. So I'm going to rewrite this whole thing. Y equals 2x plus 1. So I'm going to plug in negative 2 for x. So y equals 2 times negative 2 plus 1. And then go ahead and solve. So we have y equals negative 4 plus 1. Keep going. Negative 4 plus 1 is negative 3. So my y equals negative 3. So again, I write it as an ordered pair. So my x term is negative 2. My y is negative 3. And that is one solution. And you're going to box your answers for your teacher. Example 3. Okay, so again, y is already by itself. Everything else is on this side in this top equation. So we're going to take that, plug it into this next equation. So we have negative 6x plus 3. And then that's times y. So in parentheses, I'm going to plug in 2x minus 4, bring down my equals negative 12, and solve. So we see parentheses and a number in front, so we know we're going to distribute that positive 3 to both of the numbers in, both of the terms in the parentheses. So we have negative 6x we're going to bring down, plus 6x minus 12 equals negative 12. And then we're going to keep going. So we have negative 6x plus 6x that we can combine together. Well, negative 6 plus 6 is just 0, so those actually cancel out. So I have negative 12 equals negative 12 left. So if you notice, my variables have canceled out, so I got one of those weird answers. Negative 12 does equal negative 12. It's a true statement. So this is infinite solutions. Just a quick reminder, if you would have gotten negative 12 equals a different number, then that would have been no solution. Okay, so if you notice on example 4, both of them are in standard form, so we need to solve for one of the variables. It doesn't actually matter which one. So I know typically we've been solving for y and we want to put it in slope-intercept form. But if you look at this top equation, it seems to be that x has nothing in front, so that one would actually be easier to solve for. So to get x by itself, I just need to move the 2y over. So I'm going to subtract 2y, subtract 2y. So I have x equals negative 2y plus 6. Bring down my positive 6. Okay, so this is what x equals for right now. So I'm going to take that and plug it into this other equation. So I have 3, and then it's times x. So times what we just got for x, so negative 2y plus 6. close my parentheses, bring everything else down. So I just replaced the x for that, negative 2y plus 6. I'm going to bring down minus 4y equals negative 2. And then I'm going to solve. Okay? And notice that there's only y's left, so I'm going to solve for y. So I'm going to distribute my 3 out to both of those terms. So we have negative 6y plus 18. I'm going to bring down my minus 4y, and my equals negative 2. I need to combine like terms, so combine my negative 6y and negative 4y, give me negative 10y. Bring down my plus 18 equals negative 2. Continue to solve, so I'm going to subtract 18, so negative 10y equals negative 20. Divide by negative 10, divide by negative 10, y equals positive 2. And so we have our y value, so now we just have to go back and plug our y value in to solve for x. So I'm going to go ahead and plug it into this original top equation. It doesn't matter which equation you plug it into. You could even plug it into this new one that you created. But I'm going to choose my original top one, so x plus 2y equals 6. So I'm going to plug in 2 for y. So I have x plus 2 times 2 equals 6. And now I solve for x, so I have x plus 4 equals 6, minus 4, x equals 2. So this is obviously one solution, and I write my ordered pair as xy, which in this case is 2, 2. Alright, I'm going to go ahead and give you the you-try problem. So remember to try both of these problems to get your full credit. At least attempt both of them. Show us that you are trying, and bring them to class tomorrow with your questions.